Welcome to my presentation on how single neurons in the human hippocampus code episodic memories. Imagine an episode, you're in your favorite cafe with your best friend, and in the background you can hear music and a waiter is attending a different table. According to a theory proposed by Teyler and DiScenna more than 30 years ago, all of these features within that episode are bound in one conjunctive code to one index assembly in the hippocampus. According to an alternative hypothesis proposed by Quiroga in 2012, concept neurons code for each one of these features. So the concurrent activity of multiple concept neurons code one memory. We set out to answer which one is the case, and we did so using a simple memory association task. During encoding, we would present an animal cue, a tiger in this case, in this example, and 2 seconds afterwards, 2 associate images would show on the screen. The task of the participant would then be to imagine a vivid story involving all 3 images. This part of the experiment would be self-paced. Later on, we showed the tiger again and asked the patient how many associate images they remember. This part again is also self-paced. We have a rather large data set of 16 patients, 59 sessions, and 625 neurons, all located in the hippocampus. I'd next like to show you our analysis schematic. You can see on the y-axis the standardized firing rate, and on the x-axis the trial number. Color-coded in purple is the standardized firing rate of encoding, and orange for retrieval. We define reinstatement as the product of encoding and the retrieval firing rates. And the threshold for significant or relevant reinstatement we define through a shuffling procedure. Now, we found what we call episode-specific neurons in our dataset. It makes up about 1/4 of all single units. But we might just find a lot of those because we have a large number of neurons. So we then employed a second-order permutation test, and we found out that indeed the 147 episode-specific neurons that we found are significant. I would next like to show you one example episode-specific neuron. This is a raster plot, so every single line is one action potential. On the y-axis, you have the trial number, and the x-axis, you have the time. Color-coded again for purple for encoding and orange for retrieval. I've also adapted the transparency according to the reinstatement value in every single trial. Down below here, you can see the firing rates during all reinstated trials. So in this case, that would be trial 7 and 23. Here to the right, you can see the reinstatement values and the images that have been used for these trials. And down below here, you can see the wave shape. I'll also like to point out that there's only about 1,100 spikes in a recording that typically lasts 30 to 45 minutes. So those neurons are firing very sparse. One criticism is that these might just be concept neurons tuned to one image in that episode, which is a valid concern. So in a new data set, we added a localizer task at the end of the task of the experiment. And this allowed us to see if there's any visual response when we just show one of the images, for example, the tiger, the Taj Mahal, or Jennifer Aniston. We again found a significant number of episode-specific neurons, 32 out of 169 in this case, but not a single one of these episode-specific neurons are concept neurons. The conclusions are that single neurons in the hippocampus exhibit a memory-specific reinstatement of neural firing for individual episodes, and that these episode-specific neurons do not fire in response to individual concepts, so they're not concept cells. I'm happy to discuss anything if you have any questions,